And our guests today are Professor Manuel Collados, solar astronomer and coordinator of the European Solar Telescope. Welcome.
Thank you very much.
And the second guest is Peter Gemery, astrophysicist, who is also head of Astronomical Institute of Slovak Academy of Sciences. Welcome. My name is Otakar Horák and I'll be your host. Takže vítajte na diskusii o európskom slnečnom ďalekohľade a výskume Slnka. Dnešnými hostiami sú profesor Manuel Collados, ktorý je solárnym astronómom a koordinátorom celého projektu. Druhým hostom je Peter Gemery, ktorý pôsobí na Astronomickom ústave Slovenskej akadémie vied ako jeho riaditeľ. Moje meno je Otakar Horák, som reportérom denníka N. Budeme sa rozprávať zhruba 25 minút, potom bude zhruba 25 minút až 30 minút priestor na vaše otázky. Budeme sa snažiť prekladať zrejme spolu vyjadrenia pána profesora, takže buďte trošku zhovievaví k nám, ak to budú nejaké odborné výrazy. Takže začneme. Let's begin. Professor Collados, how is the European Solar Telescope going to move forward our understanding of the Sun? Skúsme nejakou všeobecnou otázkou, akým spôsobom posunie vpred európsky slnečný ďalekohľad naše porozumenie Slnku.
The first thing I want to say is to thank the Academy for hosting us here and giving us the possibility to show the movie, for sure, and what the project is. Thank you very much.
Profesor Collados úvodom ďakuje za pozvanie a veľmi si váži, že môže vystúpiť na pôde Slovenskej akadémie vied. The question is, how is the telescope going to move forward our understanding of the Sun?
Well, the idea with EST is that what we have heard is that we have seen that the magnetic field is the key player in everything that happens in the Sun.
Magnetické pole je kľúčom k tomu, aby sme porozumeli dejam, ktoré sa dejú na Slnku, takže preto ho treba skúmať.
And up to now we are only able to detect it and measure it in very special cases.
Zatiaľ ho dokážeme merať len vo veľmi špecifických prípadoch.
And then with EST what we want is to increase our capabilities to detect the smallest, the quickest magnetic features.
Takže, ak tomu rozumiem správne, cieľom je zrejme zvýšiť rozlíšenie, aby sme dokázali pozorovať na Slnku úplne tie najmenšie detaily.
Which in short can be summarized in few words. We want to know how this magnetic energy is concentrated somewhere, how this energy is transported to some other place and then released there.
Takže cieľom je pochopiť práve, kde je koncentrovaná tá energia, akým spôsobom sa prenáša. Maybe the very important question about is that how Slovakia got involved in this project and what it means to Slovak science to be part of this project. Čiže inými slovami, alebo po slovensky, ako sa vlastne Slovensko stalo súčasťou tohto projektu a čo to pre slovenskú vedu znamená.
This is probably a question to me. So we are involved in this project since its beginning, so since more than 10 years. More than 10 years, definitely, 14, 15 years. And we started on the basis of scientific collaboration, and step by step we were developing this idea about solar telescope and we were pushing it forward to this stage where we are now. My sme vlastne ako Astronomický ústav zapojení do projektu od jeho úplného začiatku, čiže viac ako 10 rokov a ten začiatok začal prirodzene na základe nejakej vedeckej spolupráce a následne sme vlastne postupne začali vyvíjať a zdokonalovať túto ideu európskeho slnečného ďalekohľadu, až sme to vlastne spoločným úsilím dotiahli do tohto stavu, v akom je to teraz.
At what stage of development is the telescope and when is it going to be built, Professor Collados? So in Slovak, v akom štádiu sa momentálne ten projekt nachádza a kedy sa ďalekohľad postaví?
So we are presently finishing all the design works to be ready to start construction in 2 years, approximately. Construction itself will take place in around 5-6 years. So the goal is that what we have seen here, EST, may be operating by the end of this decade.
Takže momentálne sú v štádiu, kedy dokončujú, myslím, design a suma sumárum zhruba do konca tejto dekády by ďalekohľad mal fungovať. Maybe you could explain to audience why the telescope is still not built, because we heard all the time that it's very important for the solar research and it's still not standing. So what is the reason? Po slovensky, prečo ďalekohľad nestojí, ak sme opakovane počuli, že je veľmi dôležitý pre slnečný výskum?
Very difficult question, and I think there is no simple answer, but yeah, if I go directly to the point, is that it is always about the money at the end. And if you compare it, for example, with the United States, I don't want to say that it is easier there, but if you work in a basic science, then in principle, if you convince one national grant agency, NSF, and you have the arguments and convince them, you get the money for your large infrastructure. Here in Europe, you need to convince, 22 national countries that they really should find common approach and finance this project, or it doesn't have to be this one, but also others, because the EU itself doesn't have any scheme how to finance such a large infrastructure. So you can go to roughly some millions if you apply for a Horizon 2020 or now Horizon Europe projects, but if you go to millions, then you need support from the countries. So basically, this is our bottleneck now, to convince our representatives on the political level. Takže v slovenčine problém je, ako to väčšinou už potom na konci býva, keď máte tú vedeckú časť ukončenú, tak potrebujete získať financie na postavenie takéhoto zariadenia a porovnával som to so Spojenými štátmi americkými, kde ja nehovorím, že to je ľahké, ale v princípe ten postup funguje tak, že ak presvedčíte jednu grantovú agentúru, ak máte na to dobré argumenty, tak máte teda tie peniaze na výstavbu. V Európe musíte presvedčiť všetky národné krajiny, ktoré sú do toho projektu zapojené, aby našli spoločné úsilie alebo sa rozhodli vykonať toto spoločné úsilie a financovať takéto veľké projekty, a to je komplikované. Takže teraz sme vlastne v tom bode, že potrebujeme nejakým spôsobom presvedčiť národných reprezentantov, národné vlády, aby tento projekt bol financovaný. We
heard that the Canary Islands is an appropriate location for the telescope, but tell us more maybe about the volcano Coimbra Vieja. Doesn't it pose any problem for the research? Že v tom filme sme počuli o tom, že Kanárske ostrovy sú vhodnou lokalitou na stavbu takého ďalekohľadu, ale pamätáme si, ako minulý rok vybuchla sopka Coimbra Vieja, tak či nepredstavujú takéto erupcie problém pre výskum Slnka?
Yes, the volcano was a surprise to us. It was the largest volcanic eruption since in all the history of La Palma, since there are recordings.
Takže ten výbuch bol prekvapením a išlo vlastne o najväčší výbuch v zaznamenaných dejinách.
It lasted 3 months.
Trval 3 mesiace.
And it only interrupted the observations during the times that the wind didn't flow in the right direction. So it brought ashes.
Takže v podstate Problém to predstavovalo iba vtedy, keď prach alebo častice z tej sopky mali namierené presne v tej dráhe, kde bol ďalekohľad.
Yeah, at that moment all the telescopes were closed just for protection, so that the ashes didn't damage the optics.
A v tom čase sa ďalekohľady zavreli, aby sa nepoškodila optika.
Yeah, but there was no damage during all the volcanic time to any of the installations.
Takže nedošlo k žiadnemu poškodeniu.
So as soon as the volcano extinguished, 3 months later, then the activity at the observatories resumed as normal as before.
A po ukončení tých erupcií, ktoré trvali 3 mesiace, sa práce na ďalekohľade plne obnovili.
So we do not expect that this to happen every year. The last eruption happened 50 years ago, and we did not expect this one so close in time. So next, hopefully, will happen in 200 years from now. But even with the largest eruption up to now, the damage has been nothing.
Že neočakáva sa, že by sa takéto erupcie diali každý rok a vlastne najväčšia erupcia predtým bola pred 50 rokmi, takže sa nečakalo, že príde ďalšia tak skoro.
And during the 30 or 40 years lifetime of telescopes, these 3 months changes of the operation represents nothing.
Ďalekohľad má životnosť nejakých 30 až 40 rokov, takže tie 3 mesiace nepredstavujú nejaký problém, keď došlo k zatvoreniu prác.
But I agree that we have to cross our fingers that volcanism does not change.
Ale držte palce. Now, next question is on Dr. Gemery. Why are the data from coronagraph at the observatory in Lomnický Peak so important for the European Solar Telescope and how are they going to be used? Takže skúste nám vysvetliť, že prečo sú údaje z koronografu na observatóriu na Lomnickom štíte také dôležité pre EST a akým spôsobom sa budú používať?
Because they are complementary to EST. So it is not that we will fight with EST, it is that we can nicely collaborate. It was a little bit mentioned also in a movie that we didn't want to make some compromises while designing EST, so it was not the same approach as was used in US, that they have a telescope which can observe everything, but there is always some but behind, so there is some compromise. So it is not optimized, for example, for the observations of these small-scale magnetic fields, which we not believe, but we know that they are very crucial in the whole story of the sun. So we need to concentrate on those, and as we have additional instrumentation in Europe, we can really make the mosaic of different data and then really explore the sun and use the full potential of this data. Takže vlastne my sme od začiatku neplánovali navrhovať európsky slnečný ďalekohľad s nejakými kompromismi, aby sme urobili možno síce jeden ďalekohľad pre všetko, ale nie ideálny pre partikulárne otázky. A keďže my vieme, že potrebujeme získať čo možno najlepšie dáta pri pozorovaní tých veľmi malých priestorových škálach, hlavne magnetizmu na tých malých priestorových škálach, tak vlastne sme sa rozhodli radšej ísť inou cestou ako kolegovia v Spojených štátoch, čiže nadizajnovať ďalekohľad, ktorý bude optimalizovaný na pozorovanie takýchto objektov a potom v spolupráci s už existujúcou infraštruktúrou, ktorú v Európe máme, vieme získať vlastne nejaký komplexný materiál na štúdium Slnka. And the second part of the question was how we will explore. So it is then starts the standard science. So you sit days in an office and you analyze the data. First you can analyze them just in a way what you see really in the data, and then you compare them, for example, with the numerical simulations. And if you can simulate in your computer something what looks then in comparison very similar to the data or to the observations, then you can say that your simulations with the known parameters are probably explaining what was happening on the sun, and then you can say that we know what was the I don't know, temperature, density, velocities, magnetic field, what was the temporal evolution of these structures. So this is the way, I think we will not really change that much how to use the data, but we will have better data for analysis. Čiže pre Oro, you want to add something?
Yes, if you allow me. There is something which is very important, and usually even us, we are not aware. You remind what a short time ago, theory was in one direction and observations were in another direction. Now supercomputers have made that theory goes even further, so that the comparison of what theory is predicting and what we are observing in the past has been very difficult. And only with large facilities as this one, we will be able to combine what theory predicts with what we observe, so that the merging of the two fields will make a larger progress than if we go separately.
Pokúsim sa zhrnúť slova pána profesora, že teda v ostatných rokoch dochádza k tomu problému, že sa rozchádza teória a pozorovania. A vlastne IST ako nový ďalekohľad by mal snáď, je taká nádej dospieť k tomu, že by tá teória s tými pozorovaniami sa nejako zlúčili alebo proste by sa k sebe priblížili, a to je ten progres, o ktorom dúfam, že dosiahneme, aby sa teda teória a pozorovania naďalej nelíšili. Ja ešte by som možno poprosil, aby ste vy preložili to, čo ste hovorili do slovenčiny.
Ja som sa vám snažil vlastne vysvetliť, že možno práve získaním toho ďalekohľadu nám nie je potrebné zmeniť príliš ten prístup k tomu, ako my analyzujeme tie dáta, čiže oni sa analyzujú nejakými postupmi, pri ktorých my vieme z tých dát získavať nejaké fyzikálne parametre. To je jedna možnosť, ale druhá možnosť je potom práve to, kde Manuel potom pokračoval, že vy viete, alebo vieme dneska urobiť aj nejaké numerické simulácie v počítačoch a porovnávať ich s tými pozorovaniami a na základe toho vlastne zisťovať, že ak nastane zhoda medzi tým výpočtom alebo tou umelou entitou, ktorá je v počítači nami vymyslená, ak sa naozaj zhoduje s tými pozorovaniami, tak vieme potom aj povedať, že tie známe parametre, ktoré sme tomu počítaču my zadali, tak by mali zodpovedať tým prírodným parametrom. A ďalej to teda pokračuje tým, že tie simulácie, kvôli tomu, že tu sa už bolo preložené, že tie simulácie sa čím ďalej tým viac robili dokonalejšie kvôli počítačom a tie pozorovania zaostávali, a to už sme vlastne dokončili.
Okay, my next question is on Professor Collados. Tell us more about the unique properties of the telescope. Povedzte nám viac o unikátnych vlastnostiach teleskopu.
There are many things. Unique properties of the telescope. The first is the size. The telescope is 3 times larger than any telescope of any European telescope operating at this moment.
Takže prvou unikátnou vlastnosťou je veľkosť, je 3-krát väčší ako doterajšie fungujúce teleskopy.
And as we have heard in the movie, the size implies, tells us how small are the things that we can resolve. So,
vďaka tej veľkej veľkosti dokážu pozorovať veľmi malé veci alebo veci malých rozmerov na Slnku.
The second thing is that the telescope is specially designed to measure the key actor, the magnetic field. So this is the first telescope which is specially designed for that.
Takže ide o prvý ďalekohľad, ktorý je špeciálne zameraný na to, aby skúmal magnetické pole Slnka.
We also heard about adaptive optics, which means that we will be correcting in real time the effects, the blurring effects of the atmosphere.
Počuli sme tiež o adaptívnej optike, inak to by možno pán doktor Gemery mohol viac vysvetliť, čo to znamená. Maybe Dr. Gemery could explain a bit more what the adaptive optics mean.
Thanks. Only in Slovak? Adaptívna optika je vlastne zariadenie, ktoré v reálnom čase dokáže keby nastaviť plochy jednotlivých elementov v optickej ceste svetla tak, aby ste dokázali vykompenzovať narušenú svetelnú vlnoplochu, ktorá prichádza do vášho ďalekohľadu alebo do hociakého optického zariadenia a je porušená napríklad prechodom cez zemskú atmosféru. Čiže to, čo sa v minulosti vlastne astronómovia snažili urobiť čo najdokonalejšie, napríklad získať čo najpresnejšie parabolické zrkadlo, pretože neboli iné možnosti, tak dneska vlastne chceme ísť ešte o krok ďalej, že tú parabolu sa snažíme trošku, nie zase samozrejme tak, aby stratila úplne tvar, ale trošku modifikovať a upravovať presne opačným spôsobom, ako je porušená tá vlnoplocha. A tým pádom, keď sa tá vlnoplocha odrazí od takto poprehýnaného zrkadla, tak sa odrazí ako rovná a výsledkom je potom vlastne neporušený obraz. A k tej adaptívnej optike ja by som dodal, že napríklad v prípade EST sa plánuje urobiť dokonca adaptívne zrkadlo sekundárne, veľmi veľké. A také ešte nikdy vlastne v praxi nebolo urobené, čiže je to naozaj obrovská výzva technologická, či je v dnešnej dobe vôbec nejaká firma na svete schopná urobiť takéto zariadenie ako súčasť toho celku adaptívnej optiky ďalekohľadu S. Ukázalo sa, že je to možné a keď sa k tomu pristúpi, tak to bude mať naozaj veľkú aplikáciu aj v tých samotných optických prístrojoch, ktoré sa nepoužívajú len v astronómii, pretože optické prístroje môžete používať v medicíne a tak ďalej, čiže je to taký krok, ktorý by mohol potom byť plusom aj v iných oblastiach.
Okay, now my last question. So prepare some questions if you have those. My last question is on Professor Collados. Tell us more about the sunspots. Why is it so important for us to study sunspots? A prečo je také dôležité skúmať slnečné škvrny?
Why is it important to study sunspots? Well, they are most evident manifestation of magnetic energy concentration.
Čiže ide o prejav práve magnetického poľa, ak tomu rozumiem správne?
Áno. Je to...
Then, even if they are larger than the Earth. We can put an Earth inside. They show a fine structure which we do not understand.
Sú také obrovské, že by sa do nich zmestila Zem a vlastne tej štruktúre asi zatiaľ dobre úplne nerozumieme.
Also, they usually give rise to the largest eruptions.
Vznikajú z nich aj veľmi veľké erupcie.
So, understanding how they form and how they evolve and how they disappear.
Takže cieľom je vlastne pochopiť, ako vznikajú a ako zanikajú.
Will tell us for sure a lot of information about all these magnetic processes.
A keď toto pochopíme, tie slnečné škvrny, tak pochopíme strašne veľa aj o tých procesoch, ktoré sa dejú na Slnku a týkajú sa magnetického poľa. Okay, so I think that's it for us for now. To je z našej strany asi na teraz všetko a bude teraz priestor nejakú cca pol hodinku na to, aby ste sa vy opýtali otázky.
One remark and one question. Really great that I am geologist and I really was visible on Earth that this 11 years magnetic cycle is visible also in sedimentation. So in this cycle is visible also sediment layers and it's very also important to know this phenomenon that this exists. And my question is that due to the size of the telescope, the utorok will be the leader in prediction of magnetic storm in the world. Yes, and how it works this network, and if this storm is in progress, it affect the whole globe. Or just this part which is closer towards the sun.
Skúsim ja preložiť iba otázku najskôr do slovenčiny, čiže vlastne tá otázka bola, aby som to iba zhrnul, že pomocou takéhoto ďalekohľadu by Európa mala mať vlastne líderskú pozíciu v prípade aj predpovede geomagnetických búrok. A otázka teda znie, že akým spôsobom potom funguje nejaký mechanizmus pri a k tomu chápem varovných signáloch alebo vlastne posúvaní informácií o tom, že takáto magnetická búrka by sa mala stať.
Concerning the remark, yes, I agree that the solar cycle leaves its imprint here on the ground. We can see it on the geological layers. We also see it on the trees, the rings of the trees, and somehow we can trace how the sun was much before we started observing it with telescopes. So we can trace the solar activity back to thousands of years back in time, thanks to these things. Yeah, thank you for. And concerning the enormous solar storm, well, it might happen. The probability of having a supergiant solar storm that could affect the whole globe is very low. So we do not expect that it will happen not now, but even in the next coming centuries, we do not expect that. So there are no hints that the sun may affect the whole globe. The largest solar storm that we know of is the Carrington event that was mentioned, and it happened in the 19th century, and it affected only the part that was at that moment, the part of the world that was at that moment most developed technologically speaking. But there is a fact that is important. We have the Earth has a magnetic field. This magnetic field of the Earth acts as a shield towards all these particles that are coming from the sun. Usually they are deviated by the magnetic field, and only some of them can penetrate under certain circumstances through the Earth's magnetic field. So if these particular circumstances appear, then some particular places might be affected. But the whole globe, ideally, theoretically, might happen with a super enormous storm, but at least what we know of the sun, the storms are orders of magnitude much smaller than what would be required. But theoretically, might be for.
Bol to taký balík odpovedí. Skúsim aspoň zo pár z nich. Na Slnku prebieha tzv. 11-ročný cyklus, to je taký priemerný údaj, ak tomu rozumiem správne, a vlastne tento 11-ročný cyklus na Slnku, kedy klesá a stúpa počet slnečných škvrn, tak sa prejavuje aj na Slnku. Dokonca to môžu teda pozorovať geológovia a vidíme to dokonca aj na stromoch. Taká solárna búrka, ktorá by zasiahla celú Zem, tam mierila aj tá časť otázky, tak taká zrejme nehrozí v nejakom dohľadnom čase niekoľkých storočí, ale nejaké lokálne problémy by zrejme mohli nastať. A jedna vlastne z tých najväčších búrok, ku ktorej došlo, tak tá bola v 19. storočí, je to taký Carringtonov event, tá udalosť Carringtona. Takže asi takto by som to zhrnul. Možno pán Gemery by niečo doplnil.
Maybe I can just add, I was first afraid that I would have to translate what Manuel said because I was lost at the end, it was too long, but this was just a little fun. What I wanted to add is that when we speak about the sun and we are mentioning these negative aspects that it can have some effect on our civilization or our technologies, that's true, but I always like to protect the sun, that it is happening if then on some local scale, and our big advantage is that we have the information that something is happening in 8 minutes because the photons are coming in 8 minutes, but these dangerous particles with the free electrical charge are coming in 1 day, 2 days. So we have some time to prepare, and if we have better data with EST, for example, then we will be even better prepared. So that's why we really need this telescope. Takže ja som len chcel vlastne doplniť k tej odpovedi, ktorá naozaj obsiahla veľkú časť, že v prípade Slnka je pravda, že keď sa bavíme o tom, aké má vplyvy na naše tie technológie a súčasnú civilizáciu, tak je to pravda, že nejaké tam sú, ale ja som vždycky na tej strane, že sa snažím to Slnko obhájiť, že je to predsa len pre nás veľmi dobrá hviezda a našou výhodou je, že ono nám vlastne dáva tú informáciu z predstihu, aby sme sa vedeli pripraviť, lebo do 8 minút, keď sa niečo na Slnku stane, do 8 minút tu máme fotóny, ktoré nám povedia, že sa na Slnku niečo stalo a tie nebezpečné nabité častice prídu v rámci 1 až 2 dní, takže sa vieme na tú prípadne veľkú erupciu pripraviť a keď budeme mať lepšie dáta, takého ďalekohľadu ako je, tak sa vieme pripraviť o to lepšie ešte. Takže aby som ho trošku obhájil Slnko.
Okay, so now, please, next question from the audience there.
So, as we've already heard about the solar cycle, so we know that it's a real linear periodic change in sun's activity. But how we record the period from around 1645 to 1715, known as the Maunder minimum. Some claim that this minimum may have contributed to the climate cooling, although the cooling began before the solar minimum, and its primary cause is believed to be a volcanic activity. But my question is, what is maybe your opinion on this, and maybe what are the current modern explanations for the cause of this abnormality in solar cycles?
Thank you very much for the question. You are invited to join the scientific community. This is certainly, there was a period in the 17th century where the solar activity seemed to stop. Not for 1 or 2 years, it was 70 years when there was no activity, no sunspots. At some moment, for the solar physicists, the explanation meant that the solar dynamo producing the magnetic field had stopped. But then there was the question, if you stop it, then how you run it again, which is more difficult than stopping it. I'm talking about not so many years ago, so this discussion took place not so long ago. Now the most likely explanation, and I say likely, not for sure, the most likely explanation is that the solar activity is modulated, not always has the same strength, which is somehow indicated by the fact that not all the cycles are equally intense. And for that reason, in that period, the activity continued, but the only thing is that the magnetic field was not intense enough to reach the surface. So it just stayed below. So it was there, sometimes so to say, it reaches larger and larger heights, and sometimes it stays below, and that produces the difference between cycles with larger or smaller activity. And in that time, for some reason we don't know, the activity was below a minimum and didn't reach the surface. This is the most likely, and I insist on the likely, explanation up to now. We don't have a real mathematical explanation for that, because we don't have a real explanation of how the cycle works. We don't know why the sun has an 11-year cycle. We don't know why the period is 11 years. So why it's periodic, we know. But it could be 50 years or 2 years. So we don't know exactly why it is 11 years.
Otázka mierila teda na to, že prečo došlo k takej inaktivite Slnka v 17. storočí, ktorá mala byť spojená aj s ochladením. A vysvetlenie je také, že tomu úplne nerozumieme, ale v podstate tie cykly, 11-ročné cykly sa líšia svojou silou a v tomto prípade teda nebola tá sila taká dostatočná, aby sa dostalo až na povrch Slnka, takže asi také je to najrozumnejšie vysvetlenie v súčasnosti. Možno pán Gemery by doplnil.
I would like to add to this answer, which was correct from the point of view of physics. The answer of Manuel was probably the most accurate in the physics. I don't have that accurate answer, but I had a very nice explanation of the Maunder minimum, and it is of course more for fun, but this Maunder minimum was in a time coincident with the period, or at least part of the period, when in France we had Louis XIV, the king, and his nickname, or how to say it, was the king, the sun. So we say that the sun didn't have chance to do anything in space because it was on the ground, and that's why it was not producing the sunspots up there, because part of its activity was directly on the Earth. So it is just, but probably it is not that correct. That's your answer.
One never knows.
Takže ja som len na odľahčenie chcel vlastne doplniť, že ono to samozrejme nie je žiadna korektná odpoveď z pohľadu fyziky, ale Maunderovo minimum sa náhodou vyskytlo v čase, keď vo Francúzsku vládol Ludvík XIV, ktorý bol známy ako král Slnko, takže možno, že časť slnečnej aktivity bola prenesená priamo na Zem a tým pádom nemohlo generovať slnečné škvrny vo vesmíre, alebo tam, kde je, takže to len ako alternatíva k tej korektnej vedeckej odpovedi. Urobte si obraz, že ktorá je lepšia.
Okay, so maybe 2 or 3 more questions, so please raise your hand. Go ahead.
If there is like any other telescope that is comparable with the AEST that is going to be built.
Čiže len preložím, existuje nejaký iný podobný ďalekohľad EST? Go ahead.
Yes, there is one. There's an American one operating in Hawaii. It started this year, or last year at the end of the year. It's already operating. It will have similar capabilities as CST, but it is somehow optimized for the corona, which EST will not be optimized to, and EST will be more optimized for this magnetic field determination, which doesn't mean that the American telescope will not be able to do that. It will also be able to do that, but less optimized than what we will do. So, but roughly speaking, the two telescopes are similar, but the way they will observe the sun will be slightly different. Yeah.
Takže existuje podobný ďalekohľad, ktorý sa nachádza na Havaji, otvoril sa alebo začal fungovať nedávno, ale je mierne odlišný v tom zmysle, že teda je zameraný alebo optimalizovaný na výskum korony, zatiaľ čo nový plánovaný ďalekohľad EST by mal byť zameraný prevažne alebo hlavne dominantne na magnetické pole. Okay, so please another question.
I'd like to ask, what do you deem as the greatest achievement of your work?
Čo považujete za najväčší úspech vašej práce?
It's only for you.
Are you sure?
Yeah, it is the question for you.
I changed the question to both of you.
I don't know. I am very proud of the instrumentation I have done. I am very proud of the theoretical works I have done. I am very proud of the collaborators I have. So I prefer not to answer that question. I'm sorry.
Takže pán profesor je pyšný na svoju teoretickú prácu, spolupráce, ktoré má, a zároveň aj na instrumentation, znamená vybavenie?
No, ktoré navrhol.
Nech sa páči.
Fortunately, I don't have the... No, now it is on. The easiest would be just to repeat part of things what Manuel mentioned. It would be definitely true, but maybe what I would be most proud is about the results taken or achieved by EST. So something what only will be in the future.
Yes, definitely. The most important thing is to have had the possibility in the last 10 years to work together with the different scientists of the different European institutes towards a joint project. This is certainly much more important than the other things. Yes.
Takže pán profesor ocenil spoluprácu za ostatných 10 rokov s ľuďmi zo svojho odboru a obidvaja teda očakávajú to, že IST príde s objavmi, na ktoré budú môcť byť veľmi hrdí.
And I see many candidates who contribute to this statement. That with the EST we will definitely get some new discoveries, because I see the audience and there are really many candidates, young ones.
Okay, so maybe two last questions. Go ahead, Profesor Šajgalík.
Ja začnem po slovensky. Ja si myslím, že je strašne dôležité, aby sme sa tu všetci dozvedeli, pretože aká je naša predstava o tom, čo je ďalekohľad. Máme predstavu, že vám to zliečí ako hviezdu a pozrieme sa, ako tam behajú ľudkovia po nej, v tom optimálnom prípade, ale Slnko není ten prípad. To je moja primárna otázka, lebo Slnko je strašne zložitý komplex, to sa večer dostaneme k tomu, budem sa vás pýtať. Ale čo vlastne EST dokáže? Čo vidíme? Vidíme iba škvrny, alebo rozumieme aj tomu, treba, že prebiehajú procesy vnútri, je to iba optický ďalekohľad, ale má to aj iných 1000 funkcií, lebo podľa mňa to je dôležité. Rozprávame o magnetickom poli, rozprávame o čomkoľvek. Ja si myslím, že je dôležité, aby sme my tu v sále vedeli, teda aspoň ja si myslím, že to nie je len optický ďalekohľad. I will translate very quickly. My question was long, but usually this is very short. What does it mean, European stellar telescope? Is it just the optical system, or is it a system which is much more complex, which brings us much more information, just like somebody is moving on the surface of the sun?
There is a view with this telescope of the sun that we do not have up to now. And the issue is that we want to have a 3D vision of the sun, what is happening here, here, and how it evolves, so this volume. By no way, any telescope recently has these capabilities.
How deep is this view?
This. 2,000 kilometers, the whole atmosphere. So the idea, so this is the corona, we are not seeing the corona. This is the surface, below the surface we cannot observe. So everything that we can observe, the idea with EST is that we follow what is happening in all this volume in time, in 3D, with all the instrumentation simultaneously probing the different layers. And this view is completely unique.
Maybe I can translate. Pokúsim sa preložiť, čiže bola to veľmi dobrá otázka, pretože naozaj až doteraz pri tých pozorovaniach my sme boli limitovaní tým, že sme vlastne pozorovali v optickej oblasti, ale vždycky len nejakú vrstvu toho slnka a utekali alebo míňali sme vlastne tie veľmi podstatné informácie. Ako už bolo aj povedané vlastne v tom filme, myslím, že to povedala pani Schmieder, že vlastne to slnko je 3D a my bez toho, aby sme ho nezačali raz pozorovať a skúmať ako 3D, tak sa nikdy k tým odpovediam nedopracujeme. Čiže v princípe je pravdou aj to, čo si povedal, že ono to je vlastne mikroskop, ale teraz o to dokonalejší, že to je 3D mikroskop a nie len aby pozoroval v jednej vrstve, ktorá poskytuje potom len veľmi obmedzené množstvo informácií.
So the time is almost up. Čas sa pomaly chýli naša diskusia sa chýli ku koncu, takže prosím vás poslednú otázku, nech sa páči.
Okay, thank you. My question is, how close we will come from the possibilities of what is observable from Earth to the Sun? You told that some limits are the atmosphere, some limits are the technology. How close we will get with this new European Solar Telescope from the point what is possible to achieve?
ako najbližšie sa vôbec dostaneme k tomu, čo sa dá vôbec pozorovať na Slnku.
I'm not sure if I understand the question. You mean how small is the finest detail we will be able?
If we are reaching the limits, what is possible to observe from the surface of the Earth?
Maybe whether a bigger telescope would bring even better resolution.
Yeah, no, for sure. No way. So if the final intrinsic scales of what is happening in the sun is meters. And we are talking that we will be resolving kilometers. So we will still have a lot of room until we see what is really happening in the sun. So with this we will be making a large step towards the smallest features that we see now that we are not able to analyze and to understand. We will understand that, and then we will see smallest details that we will see, but we will not be able to understand, because the final, as I say, scale that we would need to resolve is 1 meter, and to resolve 1 meter, we would need, let me calculate, 40 kilometers telescope. No 4 meters, no 40, even larger. 100 kilometers telescope. I don't think we will ever have a telescope that large.
But the mean free photon path is 1 meter?
No, this is the scale where the particles interact with the magnetic field.
Exactly, but at least we can be close to this level of mean free photon path.
Yeah,
so we see at least some level that we can reach.
That's correct. So there are many details. Yes.
Sorry.
Takže ide o veľký krok vpred, ale tento teleskop dokáže pozorovať javy na Slnku o veľkosti niekoľkých kilometrov, ale javy, ktoré vôbec možno pozorovať na Slnku, sú veľké len 1 meter a na to, aby sme niečo také dokázali, by sme potrebovali ďalekohľad veľký 40 kilometrov. So thank you for coming here to... Okay, go ahead. One last question.
I know the science, I'm just econom, and I have a question. How much is cost and how big is the budget for years here?
Very good question.
The cost is 220 million euros, which I think, or we think that for 20 countries that are involved there should be affordable. Yeah.
Takže cena za tento ďalekohľad je 220 miliónov eur. Okay, and the final words by Professor Collados.
There is one thing I would like to say. I'm not sure whether you all know. Some months ago, the project announced a contest, a prize for the sun attendance for the students of secondary, and so that they designed an infography about the sun, about whatever aspect of the sun. We received a lot of infographics from many institutes and schools from all over Europe. At the end, there were only 2 winners. And one of the second prize came to a school here in Slovakia, which I think we have to recognize. It was an impressive, good work. And the committee that analyzed, all the proposals that were received acknowledged the excellent quality of all the works that were received, but in particular, the 2 prizes. They were excellent, and I think, I'm not sure, because at that time when I met them, we had the masks. I think that the group is here, and then I would like to thank them for participating in the project, for their nice work. They visited Tenerife. I met them, but as I say, I cannot remind their faces because of the mask. And please stand up and yeah, go up, stand up, so that we can.
Then just to add, because I am really proud of the students, that there was even the second Slovak school which was very high in this contest. I don't know if it was the top 10 or top 15. This is what Luis can top 10. So in fact, in the first 10 schools from all over the Europe, there was another school from Stará Ľubovňa. I don't know if these students are so they are really here. So this is something what I really want to acknowledge a lot, because even if it is not the second place, but to be in the first 10 from how many? Luis, can you?
More than 600.
Then it is really great achievement, and thank you a lot.
Na záver by sme chceli veľmi pekne poďakovať veľmi šikovným študentom, ktorí sú na Slovensku, za to, že sa zúčastnili tohto projektu a zároveň, že v ňom aj uspeli v takej ťažkej konkurencii, takže veľká vďaka a gratulujeme. This is the end of the discussion, so I would like to thank Professor Collados for coming to Slovakia. And also Dr. Gemery for the discussion. Thank you. Ďakujeme veľmi pekne, že ste sa zúčastnili tejto diskusie a verím, že sa vidíme aj na budúce.